What's up guys, welcome back to K.D.P programming, and in today's video we'll be continuing with data structures. In the previous video we spoke about queues, and if you ever watched that video, I highly recommend that you watch that video first, because everything that I'm going to show you in this video is going to make much more sense if you first understand that video, because whatever you're going to be doing today, it's going to be more of a transition from that video to this video. So if you haven't watched that video, I highly recommend that you watch that video first. I'll put the link to that video in the description box below, or you can click on the pop-up in the screen. So without wasting any time, let's get straight into this. One thing I always like to point out in these videos is these are not language-based videos, these are concept-based videos. So meaning I won't be going to a tier in a specific language, but rather I'll be focusing more on the concept, trying to show you how a specific concept works. So if you're coming from a different background or different programming language, you're more likely to still understand what I'm trying to explain. So what exactly is a stack? So a stack is a linear data structure in which insertion and deletion are allowed only at the end or at the top of the stack. So whenever you're thinking of stack, just think of a pile of books, like a stack of books, one book on top of another. So the reason why I said you guys should go and watch the first video or the video on queues before coming to this video is queues are literally like, stacks are literally like queues. It's just that stacks, they are flipped vertical. They behave the same, we just have to put a few tweaks here and there. So I'll give an example. Here on the screen, we have an example of our stack. So when our stack started, it was empty. It was like this. And then we had an empty stack. And then we insert a data or an element into our stack. So just like queues, but in queues, when you insert your data, we said we do what? We enqueue. So this is the same with enqueuing, but in this case, we are pushing to a stack. We pushed an element of 1, then we pushed another element of 2. So you can just see that after you pushed your element of 2, it became on top of the element that was already here, which was 1. So just like queues, when you push something in a queue, it goes to the back of the queue. But in this case, it doesn't go to the back of the stack, because stack is vertical, but rather it goes to the top of the stack. And then you push another element, which is an element of 3. Then after pushing, you have what you call pop. Pop, it's the same as dequeuing in a queue. So we said that dequeuing was removing the top element or removing the last element in your queue. But here we're saying pop is the operation that takes the last element in your stack. This is exactly how dequeuing behaves in queues. So the reason why I said you guys should go back and watch that video is I don't want to make this video long, because literally the concept is the same, and I don't want to go through code trying to teach you this and that, because it's literally the same thing. If you get the concept of dequeuing, this is literally the same. You just have to flip your stack vertical, then everything will make sense. So the previous things that we went through in the previous videos is we spoke about things like enqueue, and like I said, in this case is to push. So you're inserting a new element into your data structure. So we'll just say this is equivalent as inserting. Then in queues, you had dequeue. Here you have pop, and pop is removing your top or your last element. And last but not least, we had peak. And if you remember correctly, we said that peak, it's when you want to check what is the next element or what is the element that is at the top. But when you peak, you don't remove your element from your data structure. You just want to look at it and work with it. So it still behaves the same. You can still pick stack just how you pick your queues. The element is not removed. You just pick, you just look at what it is, then you work with it. So peak still works as peak. It's the same as you just looking, you're not removing. And last but not least, we spoke about the concept of FIFO in queues, which is first in, first out. That is because queues have two openings. Queues are like this. They have an opening here and they have an opening here. So when you insert something in a queue, it comes it gets inserted from the back, and when you remove something, it gets removed from the front. But your stack, they work quite differently. Like I said, it is the same as this, but just flip it vertical. Since it's flipped vertical like this, you can't remove anything at the bottom. So elements, they come like this, straight down, and when you remove them going up. So since you have your first book here, you have your second book here, and you have your third book here. To get your book 1 here, you first have to remove these 2 books. So when you pop, you're only popping the element that is at the top, which is going to be your book 3. So this introduces a concept that we call first in, last out. So it's quite different with queues. Queues is first in, first out. In stack is first in, last out, or you can call it philo. So that's pretty much all I had to say about stacks. So it's literally the same as queues. I don't want to go back and forth and show you code of this. It's literally the same. You just know that whenever there's a queue, whenever there's DQ, just replace it with pop. Whenever there's in queue, it's push. Pick is still pick. The operation works quite different. You have one opening which is the top. It's where your data get inserted in, and it's where your data gets removed. Instead of first in, first out, is first in, last out. So if you got to watch this far, don't forget to subscribe, and I'll see you guys in the next video. So cheers.